I'm going to do another one. This is 21C. Question 6, I think it was. I thought, no, 7. I thought I'd do 7 because there's no diagram. All right. Even if there is a diagram, I want you to draw one, but the reason I chose this is because there was no diagram. I thought it might make the question a bit harder for y'all. So we draw our circle because every question has a circle. P is any point on a circle. I'm going to put it up the top of the circle, I think. There. And label it as P. QR is a chord in the circle parallel to the tangent at P. So there's a tangent at P, which I'm going to try and draw somehow. All right, there's my tangent at P. We have a chord. We could put it up there. I think I'll put it down low. Presumably, the fact that the chords, it says it's got to be parallel. We have a chord QR. Right, so I can label that. That's parallel to this tangent. Now, I assume that that's important. I think that if it wasn't parallel, this question wouldn't work because we've got to show that or prove that the triangle PQR is isosceles. PQR. So I'll draw in this triangle. Should be isosceles. Mine doesn't look isosceles, but it, it's just a sketch. So that's parallel. Okay. So I'm going to change the screen. PQR is isosceles. It doesn't matter that my sketch is a bit dodgy. What matters is that I communicate the answer and get the answer properly. So using the idea of parallel lines, okay, I'm drawing in two parallel lines. We could think of, we've got like a transversal there, PR. Maybe we'll stretch it out a bit. We've got our P here, we've got our parallel lines. Perfectly drawn, I know. Just, I want to say this angle's the same as this angle. All right, that would be alternate angles. We could say, you've got corresponding angles are equal. I can't really see that. I suppose we could have co-interior angles adding up to 180. Yeah. Let's try this. Okay, so I'm saying we'll put in an angle here. I'll call it alpha, and I know that that angle's there is alpha. Okay, I think I've solved it because this angle out here has to be alpha, angle between tangent and chord. And if those two angles are both alpha, then this triangle has to be isosceles. All right. So, question 7, wasn't it? We need to say angle. Oh, all right, we'll say label. It's like I need another point. What comes after R? T. How do I communicate this? I might put another point on this tangent. All right, so if we have an angle R, P, T, I'm communicating by saying that I'm labeling this angle alpha. Label alpha. Sorry, terrible. That's a terrible alpha. Right, so it's like that's step 1. Step 2 was, therefore, the angle at QRP equals alpha, and the communication, the bit I'm worried about, is that we knew that because of alternate angles, right? And I just drew a sketch of that using parallel lines. So again, curly brackets, and you write your explanation. If you don't do that, you're not getting full marks on these questions. We can also say the angle, maybe also, the angle here at Q, RQP, RQP is alpha. How did I know that? Because I have a theorem, and it's the angle between tangent and chord. Oh, what's the wording on this? Is that the right wording? I might double check that in the book. Just to match exactly what's in your textbook. On page 456, it says angle between a tangent and a chord. Angle between a tangent, I'm not sure what I said, but it wasn't that. A tangent and a chord. Theorem. Alright, so we're saying that this angle here is the same as this angle here because we've got an angle between a tangent and a chord. There's the chord there, PR. Now the angle that's subtended by that, there's an arc that's made there, or from the chord, we say there's an angle that's subtended, right, from that chord, and the angle's equal to this one, right? So this is how you'd communicate it. You say brackets, here's the theorem I used, right? All right, so therefore, triangle PQR is isosceles. PQ isosceles, because you've just showed that you have two angles the same and they're both alpha, right? You know that. Here's your isosceles triangle. We've shown this. If those two angles are the same, then those two side lengths are the same, etc., etc. Even though it doesn't look like it in my diagram, that's just because I've drawn the circle badly. But I have finished the question here, right? So that's all you need to do for that one.